Hello and welcome to video 3 in this 5-part series where I go through examples from each of the topics covered in this unit. So in this video we're looking at exercise 2G, which focuses on inequalities, and I wanted to spend more time on this topic. I think because we had so little time to do it in class, I think it's good to give you a variety of different examples to work with just to help refresh your memory and help you with your study for this topic on the exam. So we're looking at question 2 here, and specifically, let me get out my pen, specifically 2A, which is asking us to show each of these inequalities on a number line. So first I'd write my inequality, so x is greater than or equal to 1. And I need to show this on a number line, so all I'll do is I'll draw my number line underneath that. And I will, so 1, so let's show a couple numbers on either side. So I'll put 1 over here, and let's put 0 over here, and 2 here, and 3 here. And we know that x is greater than or equal to 1, which means x could be 1 as well. So I draw a filled in circle. So that's when it is greater than or equal to, we fill in the circle, and then there's an arrow pointing to the right, because it extends on forever in this direction. Let's look at 2b. So 2b asks us to find x is less than negative 2. Again, I will draw myself a number line, and I'll start with my number in question in the middle, so negative 2, and so this will be negative 3, this will be negative 1, and let's see if we can fit a negative 4 in there as well. And we know x is less than negative 2, so it can't equal negative 2. Negative 2 is not included in that set. So I'm going to draw an open circle, and it is less than that number. So an arrow going that way, and that's part B. And finally, I've got part D here, so let's write that down. Part D, this has an upper and a lower bound to it, so we know negative 2 is less than or equal to x, which is also less than or equal to 2. For the third time, we draw a number line, and I'm going to have both negative 2 and 2 in this, so I'm actually going to start drawing my number line at 0. So there's minus 1, there's minus 2, and on the other side we have 1 and we have 2. Negative 2 is a less than or equal to, so I fill that in. And it's not an arrow because it doesn't go on forever, it keeps extending all the way up to 2, and I fill in my bubble there as well. So that is how you would represent this on a number line. Looking now at question 4, and we're required to find the solution set for each of these inequalities. So this is to say, let's solve these equations for x, or for m in this case, for the case of question I. So we'll start with 4a, and I'll do this one in a decent enough detail so you can follow along. So let's write 4 minus 3x is greater than minus 8. I'm going to solve this the same way I would solve any other algebraic problem. So I'm going to start by removing my number term from the front here. So we've got a plus 4, so I'm going to subtract it, and that gives me minus 3x is greater than minus 8 minus 4, which is minus 12. And then I can divide both sides by minus 3. Notice we have one rule when it comes to inequalities, which is if we divide by a negative number, we reverse this sign here. So all I'm going to do is minus 3 over minus 3 is 1, so we've just got x, and we flip the sign now is less than minus 12 on minus 3, which is 4. And that is the answer to our question. Moving on to part B. Part E. I arranged these myself, so you'll notice that some of them are out of order. So part E, we have 5 minus x is less than or equal to 11. I'll try and do this one quickly. So we subtract 5 from both sides. That gives us minus x is less than or equal to 6. And then I can divide by negative 1 or multiply by negative 1, whichever you like, to give me x is greater than or equal to minus 6. And we're done here. As I did in the last video, for question I, I'm actually going to give you a moment to try this one yourself. And I do encourage you to try these yourself. It will help you with your exam revision. So the question is minus 6m minus 14 is less than 15. So take a couple moments, think about it, and we'll come back and see what the solution looks like. Okay, so that should have been long enough. You may need to pause the video if you want more time. So we're going to add 14 to both sides, get rid of this extra number term here. So add 14 to both sides, that gives us minus 6m is less than 15 plus 14 is 29. And we're going to divide by minus 6, which requires us to flip this arrow here. And that gives us m is greater than 29 over, minus 29 over 6. Okay, so we're looking now at question 10, and I just wanted to do one of these, so I'll do question A, and I'm actually going to leave question B as an exercise for you to complete on your own. So, part A here, we want to know how many integers, which is how many whole numbers, satisfy both of the given equations. So here for part A, let me get out my pen again. For part A, we're given the two equations, 2x plus 1 is less than or equal to 5. And we also have 5 minus 2x is less than or equal to 5. What I'm going to do is actually, let's make that look a bit more like a 5. I'm actually going to solve these off camera, and then we'll reconvene when I've solved them for x. Right, so I've gone ahead and I've solved these, and now we have two very simple inequalities. We've got x is less than equal to 2, and we've got x is greater than equal to 0. And what I can do in order to solve the problem that I've been given is I can actually combine both of these, because I know how large x can be. This is the largest x can ever be. And I also know how small x can be. This is the smallest x can ever be. So I can now draw this in terms of two bounds or boundaries on x, which is we know 0 is less than or equal to x. All I've done here is I've taken this equation and I've just flipped it. So we can write it 0 is less than or equal to x. These two are the same. So I write 0 is less than or equal to x, and we also know x is less than or equal to 2, so I can write that is less than or equal to 2, and I now have both of these bits of information in the one equation, and I can solve this. I can list all of the whole numbers that are in this range. 0 is in this range, 1 is in this range, and 2 is in this range, and that is our answer. Okay, so what I want you to do now is to give part B a go yourself. I'm not going to do it on video here, but I do highly recommend that you have a look, give it a crack, and see how you go.